Welcome to the Practical Physics walkthrough. Today we're going to have a look at Charles' law. We're going to investigate a relationship between temperature and volume, and hopefully finding an experimental value for absolute zero. So here we've got the equipment, and you will find that you have got you'll have found that you need a tripod and a gauze and a Bunsen burner and a heat mat. This setup here is the Charles law apparatus. You get that from the prep room, and you also get a bag of ice which you have to crush. Right, let's quickly whiz through the experiment itself. So, sorry guys, just give me 1 second. It's frozen, the pigging thing. So we've got, sorry I'm slightly out of shot. The really crucial thing is that when you look at this, you can see that there's a column that's the thermometer and a second column that is air that's trapped with a teeny bit of mercury just by the 8 there. And that bit of mercury is trapping a column of air. It's open to the atmosphere at the top, and what that allows us to do is change the temperature, and as the temperature increases inside here, it will push the mercury up, maintaining constant pressure within here, but increasing the volume of temperature. That's the idea anyway. The really important thing is to make sure that that column is completely submerged. We want to get a big range of values, so we can go all the way from 0 through to 100. So you put your crushed ice in here, fill up with some water, now because I've got a mix of ice and water, I'm just going to give it a little stir. I know that this water is now at 0, or as close as darn it. I think I probably should have put a little bit more ice in there, but ideally we'd just clamp this off the bottom. Or they might get away with it actually, because both the thermometer and the column are going to be held just off the bottom of this plastic rod. So I'll just keep lifting it up and being able to look. So you've got to give it a minute, let the water temperature just decrease to as close to 0 as you can. If it doesn't quite get to 0, it's not the end of the world. So I'm assuming you all know to light a Bunsen burner with the safety flame on yellow. So you close off the thing, light it, open it up for blue, and you can heat it up fairly rapidly to start with. But you need to keep a close eye on that temperature and make sure that you're taking volume and temperature readings precisely. If you get those wrong, your results will be massively off. So you have got to do it carefully. You can turn down the gas tap, so don't turn it to a yellow flame, but you can turn down the gas tap by just decreasing and increasing that, just like you would at home with a cooker. So at the moment, we've got this down to only 10 degrees. Well, you might have to live with that, but ideally I'd put more crushed ice in there. And I've got the mercury column, you can see is just below 8. So the temperature is about 10 degrees, I might be able to get that lower with more crushed ice, and I've got that little bit of mercury just there at just below, it's nearly 7.4 now, because the bottom of the column we'll be using. Right, turn the Bunsen burner on and heat the water up. Heated it some time now, and you can see that I've got I'll just take it out. It was about 60 degrees, and I've got 9.5 on there. Put that back in. Make sure I've submerged the mercury. So 70 degrees, and yeah, well over 9.5 there. It will of course decrease as we're looking at it. So the script that you'll be working through does ask you to write a small about safety precautions. Clearly that's going to be making sure that you understand the safety precautions for using a Bunsen burner, set up a little bit of theory, but more importantly it talks you through how to plot this graph. Clearly to plot the whole thing is useless, so what you're going to have to do is just plot this bit, trying to make sure that you absolutely maximise on your graph paper, and then using y equals mx plus c to find the x origin. There are a few little questions there just to make sure you've understood the theory. You will have done this before, so you will have done this in the classroom before you have come to it in the lab. Hope you found that useful, and I hope you enjoy the lab.